All right, here's another problem number 5, and this is same thing. It's a we know it's a rational expression because it's got an x in the denominator. First thing I look for the vertical asymptotes, which would be a positive 2. So to sketch the picture, I know at positive 2 there's going to be a vertical asymptote. Make sure you label that fella. Next thing, don't forget to factor that top. That will be x plus 6 and x minus 1 over that. So to find your zeros, it's just whatever makes the top 0. That'd be negative 6, 0, and 1, 0. So at 1, 0 and at negative 6, 0, you've got 2 zeros to this function. Third thing, and this is the one that's going to be a little weird, horizontal or oblique asymptotes. Because the exponent on top is bigger than the one on bottom, there is no horizontal asymptote. However, there is an oblique asymptote. For oblique asymptotes, they only work if the exponent on top is exactly 1 bigger than the one on bottom. If that was x to the third over x, that'd be 2 bigger. They wouldn't have an horizontal or an oblique asymptote. But because there's just 1 difference between the exponents on top and bottom, it's going to have an oblique asymptote. And the way you find that oblique asymptote is dividing these things out. You will say x minus 2 divided into x squared plus 5x minus 6. So it'd be x squared minus 2x, and you may be wondering, can I use synthetic division? And the answer is yes, you could. And the next thing you do is say plus 7, there'd be 7x minus 14. When I subtract that off, I get a positive 8. I do not care about the remainder, okay? The remainder does not matter to me. The only thing I need is this fellow right here, because my oblique asymptote is always going to be y equals what that division came out to be, y equals x plus 7. So that's going to be my oblique asymptote. Now, how do you sketch the line y equals x plus 7? Well, that starts at a positive 7, and it goes up 1, right 1, up 1, right 1, and it's going to look something like this if I'm not mistaken. And I'll label that asymptote. All right, and I'm going to extend this fellow up because I like to see where those things cross up there. All right. Now, keep going with what you were doing. The next thing is the y-intercept. We need to find out where the y-intercept is. We need to plug in 0 for this function. That makes that go away, that go away, that leaves you negative 6 over negative 2, which is a positive 3. So my y-intercept is 0, 3. And then the sign chart. Remember, the critical numbers on the sign chart come directly just from the vertical asymptotes and zeros only. I don't care about the rest of this. So that would be at negative 6, 1, and 2. Put them in order on a number line. If I pick a number bigger than 2, like a 3, and plug it in here, that'd be 3 plus 6 is 9. 3 minus 1 is 2. 3 minus 2 is 1. Positive, positive divided by positive is all positive. And since no 0 is repeated, it's going to alternate positive, negative, positive, negative. So I've done my sign chart. So on the right side of 2, it's got this asymptote to hug and that asymptote to hug. Do you see it? I'm right in the middle of my math. It's going to hug that asymptote and then turn right around and go that direction as well. Do you see that? It's going to go hug this vertical asymptote and that oblique asymptote because it can't cross that asymptote on the outside edges. Okay? The next one, between 1 and 2, is below the line. Between 1 and 2, got to go through that point, got to go below that line. The next one's going to be above the line. It's got to go through the y-intercept, and it's got to come back and go through that point on the x-axis. And then out here it's got to be negative, so it means it's going to go below the axis, and it's got to hug this asymptote. So this thing's going to get closer and closer over there. There's that picture. Basically two weird curves. It's that one right there and then this one up here. That's pretty neat, huh?